Okay, so lesson 2 in our workbook, really the first lesson that could be tested on the diploma exam is operations with functions. And we're actually looking at 4 different operations on our functions: the sum, the difference, product, and quotient of f and g, any general function. Now, for this lesson, we're going to be focusing in on simply the sum and the difference of two functions. Now, what you need to remember is this part of it. So if you see something written like this, f plus g in brackets of x, not multiplied by x, but of x, that is the same as f of x plus g of x. And also, same idea with the difference. If you see in brackets f minus g, bracket, and then bracket x, that means f minus g of x, and that can be written in a different form, and it is the same as f of x minus g of x. Okay, so we're going to be using those two, if you like, formulas. Not that they're provided for you on your formula sheet, you just need to remember those to do this lesson. Okay, so first of all, we're going to look at this part of this first investigation. Okay, so you're given a table of values for the functions f and g of x. And they tell you it's defined for all real numbers. So even though they've given us a few values for x, we actually have all possible values for x. Okay, and they've given us the value for f of x, which is really the y value for f of x. And they've also given us the y values that correspond to these x values for g of x. So as ordered pairs, you could think of that as -4, actually I'll do a different one because those two are the same. You could think of the ordered pairs as -3, -5 for these two, and then that would be f of x. And you could also think of an ordered pair for g of x would be -3, -6. Okay, so that's how you read that table. Now, let's scroll down and see what they're asking for. Plot the points x, f of x. Okay, so as I was pointing out, this would be an example of one of those points on the grid, and sketch the graph of y equals f of x for x as an element of the reals. Might be handy on this part to have colored pens or pencils to be able to differentiate between the different graphs, because we're going to end up with 4 different graphs here. So 4 different colors would be good. Do it in pencil first in case you have to erase. And I'm going to plot my points. I'm going to first start with f of x, so -4, -7. So we'd go over -4, go down to -7. There's a point on f of x. Then I'm going to continue down and finish plotting f of x, -3, -5. -3, -5, etc. I'm going to finish plotting those. You guys go ahead and do that as well. So pause the video, and then we'll check and make sure we both have the same values for f of x. Okay, so this is what you should have ended up with, and I would use a ruler because it appears to be a straight line, and we are going to connect the dots and extend past, mostly because in the question they said that it's defined for all real numbers, so that means our x values could go on forever left and right. I'm just going to label that f of x up here, and then I'm going to use a different color, and I'm going to do the same thing for g of x and plot the points for g of x. Just keep in mind when we go to do that, g of x, you're using this x value and this y value. So -4, -7, same point. Next one would be -3, -6. Okay, you guys go ahead and do that. I will as well. Pause your video and we'll see if we get the same line. Okay, so does your g of x graph look like my g of x graph? Should be a straight line again, and a little less of a slope on that. Okay, let's see what our next step is. Part C, complete the tables above for f plus g of x. Now remember, when you see that, we know that's the same as going f of x plus g of x from our initial notes up above. Okay, and for f minus g of x, so that would be f of x minus g of x. And then sketch the graphs of each of those. Okay, so to figure that out, we are going to add for f plus g of x, we're going to add the y values, okay, of f of x and g of x. That basically is what that means. Remember, f of x is like y, so f of x plus g of x would be like adding the y values. So negative 7 plus negative 7 is going to be negative 14. Okay, next one, negative 5 plus negative 6 is going to be negative 11. Negative 3 plus negative 5, negative 8. Okay, so you go ahead and fill those in. We're also going to fill in f minus g of x, and that is the same thing as going f of x minus g of x. Okay, and we'll fill those ones in. Negative 7 minus negative 7 is going to be 0. Negative 5 minus negative 6 would be negative 5 plus 6, which would be 1. All right, you guys fill in the table, and then we'll check back and see if we have the same thing. Pause the video. Okay, so filling in those tables, let me just finish up these numbers here. We should have those values. Hopefully you arrived at the same values. Okay, and then they also want us to sketch the graph for each of those. So again, I would do f plus g of x in a different color than what we've used already, and f minus g of x. Just remember, when you're doing that, the x value is coming from this column. The y value for each graph will be from here. Okay, and then from here for our difference. All right, so I'm going to do that. You guys do that, and we'll see if we get the same graphs. Okay, so I've plotted my sum and difference functions of f and g. So in the light green is f plus g of x, and I used the first column for my x value and this column for my y value, and I've gotten this graph. Okay, and then same idea with f minus g of x. We could have also just used the values on the graph and done it in our head if you were able. So if I'm taking the red and the blue graphs and I'm adding them to get f plus g of x, I take the y value. So notice at this point, same x value. They have to have the same x value. You would take negative 7 plus negative 7 and you get negative 14. This point here, f, which is negative 5, plus g, which was negative 6, negative 5 plus negative 6 gives you negative 11. So keep in mind, if you were given ordered pairs, you would have to make sure the x coordinates of the ordered pairs are the same. Otherwise, you can't add the y values together. It doesn't work. Okay, and there's a question in your assignment that you'll need that piece of information for. Okay, let's continue down and see what else we need to do. Okay, the functions f and g on the previous page are f of x equals 2x plus 1 and g of x equals x minus 3. Write the expressions for the functions f plus g of x and f minus g of x. Okay, so again, recall, given our notes on the first page, that f plus g of x, written like that, is the same as f of x plus g of x. So what we're going to do is f of x, we know, is defined as 2x plus 1. So we're going to scoop f of x out and put in 2x plus 1. Okay, and we can use brackets to show that we scooped it out. Okay, g of x is equal to x minus 3. So we're going to scoop g of x out and put in x minus 3. Okay, now let's take a look at that. Can we simplify? Yes, we can. We can add the like terms, because we're adding here. 2x plus x is going to be 3x. And we can add the like terms of 1 and negative 3 to get negative 2. And there is our function, 3x minus 2. Now, something I want you to take note of. 3x minus 2, if we pretend this is y for a minute, because we're talking f of x and g of x, so that's y. Let's compare. We know that's a straight line, the equation for a straight line, with a y-intercept of negative 2 and a slope of 3. So let's go back and look at our graph for f plus g of x. Does it have a y-intercept of negative 2 and a slope of 3? So f plus g of x, that's our green graph. Y-intercept, hey, negative 2, look at that. And the slope would be rise over run, so from this point, 1, 2, 3, up over 1. What's our slope? 3 over 1, so 3. that is the same as the equation that we arrive at when we add the two individual functions together. Not a coincidence. Okay, let's do the same algebraic process for f minus g of x, although we do know from our notes on the first page that that is actually the same as f of x minus g of x. First function minus the second function. Okay, let's substitute in. F of x is 2x plus 1 minus g of x, which is x minus 3. Now on this one, very important, because we're subtracting, to keep x minus 3 in brackets, because that negative will need to be distributed or multiplied through the brackets. So first let's do that. Let's drop the brackets, multiply that negative through, and look what it affected. Negative 3 is now positive 3. Okay, one more step. We are going to collect like terms, and we should end up with x and positive 1 and positive 3 gives us positive 4. So we should end up with x plus 4. Okay, E, F, and G, we are going to, and H, we're going to skip those for the sake of time, as well as part 2. So let's scoot down to take a look at the next example. Okay, example number 1. Okay, on example number 1, we are going to look at basically the algebraic processes here, and they want us to, here's our original functions, f of x equals x cubed minus 2x squared plus 6, and g of x equals x cubed minus 2x plus 6. They would like us, on part A, to find expressions for f of x plus g of x. Okay, simple enough. F of x we know to be this. So we are going to sub that in, x cubed minus 2x squared plus 6, and then plus g of x we know to be that expression. So we're going to sub that in as well. If we were subtracting, I'd want to make sure we put brackets. So let's get in the good habit of doing that and just put brackets around it anyways. All right, now that we have that, we want to collect like terms and simplify this. So x cubed and x cubed, add those together, we get 2x cubed. X negative 2x squared. Oh, this other term here is not an x squared term. So there are no like terms with that. So we'd have negative 2x squared, then minus 2x, because there's no like terms with that, and then 6 plus 6 will be 12. And that's our expression for f of x plus g of x. Okay, let's do it for f of x minus g of x. Or, if you guys want to try it, pause the video now, and then we'll see if we get the same answer. Okay, so the answer we should have arrived at is negative 2x squared plus 2x. Did you remember to multiply that negative 1 through the brackets? That is the most common error that students make. So when you do that, you get negative x cubed, then negative times negative 2x would be positive 2x, and negative times positive 6, negative 6. So now when you're collecting like terms, x cubed and negative x cubed, remember the sign in front of the term is part of that term. So those will equal 0. Negative 2x squared, nothing to collect with that. Positive 2x, again, unlike term to anyone else. And positive 6 and negative 6 will equal 0. Okay, complete the following statements. F of x plus g of x is a sum, that's the word for adding two functions together, and can be written as f of f plus g of x equals. Okay, now I'm assuming what they want here is our answer from up above. So we are going to write that in there, 2x cubed minus 2x squared minus 2x plus 12. Okay, f minus g of x, f of x minus g of x is a difference of two functions, f and g, and can be written as f minus g of x, and that would be negative 2x squared plus 2x. Okay, we're going to finish off this example in part 2 of the videos, and we'll see you there.